Okay, let's take a look at this first one. We're talking about before and after. I apologize about my voice. I've been sick all weekend. A car is driving at a velocity of 24 meters per second. So that's what it tells us it's doing right at this moment. If its brakes can supply an acceleration of -5 meters per second squared, how much time will be required to bring the car to a stop? So it's coming to a stop at the very, very end. So I know that this 24 meters per second is going to be my initial velocity. I noticed some of you put this as your acceleration. Your units do not support that, right? Meters per second squared is your acceleration. 24 meters per second is your velocity. And then if it comes to a stop, my final velocity is going to be 0. It says how much time, so that's what I want to know. And then it also says that your acceleration is equal to -5 meters per second squared. So I'm looking at my kinematics equations and I only have initial velocity, final velocity, time, and acceleration. So if I look at my booklet on my chart, my kinematics chart, I don't have my displacement and I don't need my displacement. So this is going to be that first equation. So I want to write out V is equal to V sub O plus AT. And then we want to find out what T is. So please do not fill in the numbers right now. What will happen is you'll lose track and then you'll end up making math errors. So we know that A is connected to T by multiplication, so I'm going to subtract V sub O. So V minus V sub O equals AT. And then to get rid of the A, I'm going to divide both sides by A. So this is your equation that you're going to end up using to find your acceleration or your time. Once you have that, right, we know that our final velocity is 0. Our initial velocity is 24. That time is going to be -24 meters per second over -5 meters per second squared. And so this is going to end up being in the ballpark of 4.8 or so seconds for number one.